Hi everyone, in this session we are going to understand about the basic concepts of Hamming code. On completion of this session, we will able to understand the basic concepts of Hamming code. Mainly, we have to know about the types of codes. Codes are mainly classified as block codes and convolution codes. Block codes simply consists of n number of bits and one block or one code word. So code words consists of k message bits and n minus k redundant bits. Convolutional codes is a coding operation, the discrete time convolution of input sequence with the impulse response of the encoder. So linear block codes coming under the category of Hamming code when the distance of the linear block codes is said to be minimum value is said to be 3. These codes are used to used for error detecting and some error correction capabilities. So there is some error detecting and error correction capabilities of Hamming codes to conditions that to be satisfied. So the methods for controlling errors, there are different types of methods, sir. One is forward acting error correction method and reverse acting error correction method. The types of errors can be random errors and burst errors. So some of the important error controlling codes are block codes and convolutional codes. The block length can be determined as r equal to k by n. So always the block codes are determined by n comma k. So a code is said to be Hamming code when the minimum distance d is equal to 3 and it can able to detect 2 errors and able to correct 1 errors. Hamming weight of the code scheme is the largest number of ones in the valid codes, that is called as Hamming weight number. That is simply we can tell the maximum number of ones, that is called as Hamming code. So message the block diagram of the linear block code states that the message bits, that is k bits, with the check bits n minus k bits. So here x is equal to m connected with c, that is called as code word x, where m is the k bit message vector and c is the q bit check vector. And the concept of Hamming distance. Hamming distance is the total number of ones should be calculated for Hamming weight, and the weight should be the lesser weight is always is equal to 3. That is called as Hamming distance condition. So here the generator matrix. Generator matrix is represented by the letter capital G. G stands for the generator matrix. So always x is equal to code vector x is equal to mg, and generator matrix should be of the size k into n size, k cross n size. K number of rows and n number of columns is the size of the generator matrix. So G is equal to k cross n. It is represented as G equal to I, that is the identity matrix concatenation with p k cross q. P is nothing but parity matrix, and H is called as parity check matrix. P should be of size P1, P2, P3, etc. up to Pk cross Q submatrix. P is nothing but submatrix, parity submatrix, and C equal to M into P. Next, H is nothing but the parity check matrix. H equal to I n minus k into P transpose is nothing but parity check matrix. The encoding of Hamming codes can be done by different steps. First, calculating the redundant bits and positioning the redundant bits and calculating the value of each redundant bits. That is the steps for calculating the encoding the Hamming code. So first step, calculating the number of redundant bits and positioning the redundant bit and calculating the value of each redundant bits. So by using odd parity and even parity checker, we are positioning the bits. So a code is said to be a Hamming code if the conditions such as q is the number of check bits q is greater than or equal to 3, and block length n equal to 2 power q minus 1, and message bits k equal to n minus q, and minimum distance 3 all these conditions should be satisfied, and it should detect 2-bit errors and correct single bit error, and all these conditions are satisfied, then that is called as Hamming code. So decoding of Hamming code involves some 4 different steps. So first one, calculating the number of redundant bits, that is positioning the redundant bits, parity checking, and error detection and correction capabilities. So that is simply reverse of the encoding process. After encoding, decoding should be done on the receiver side. Hope you all understand this session. So we have one quiz question based upon Hamming code. That is, why do we require Hamming code? That is error detection, encryption, decryption, bit stuffing. So here answer is error correction. So Hamming code is for error correction probability. Hope you all understand this session. Thank you for watching.